of ES6. So just throw them out. What are some features that came out with ES6, just to see how many we can recall? Arrow functions, okay. It's a good start. Rest, and the same thing is called something else depending on where you use it. Yep, rest and spread. The better word I like for rest is gather, but it is called rest. What else do we have? What's that? Yep, we have object and array destructuring. Destruct. I don't think that's how you spell it, but we get it. What else? String literals, which are just backticks with $ curly brackets for variables. Any others we can think of? There's one real obvious one that you may have forgotten is ES6. Instead of var, const and let. In addition to this, we have object literals and default parameters for functions. I think that's the entire list. Got most of them. Let's double check here. Yeah, that's it. And I've got my nifty tool back up and running. What do I mean by that? All I have to do is say this word into my console, not that word, this word, and it will give me a random name. So Moroni, welcome to the random name generator. We'll be using it for the rest of the course. You will be called on randomly, but you still can phone a friend, so it's not that bad. Moroni, how do I change this to an ES6 function? Okay, your voice today. You can whisper as soft as you need. Okay, so instead of function, I'm going to rewrite it here without changing the one up there. So instead of starting with the word function, what do I start with? So like A, B, like that. It's Monday. What are we missing here in the declaration? Okay, so we need to set it equal to something. Then what needs to come before the function word? Yeah, we declare it. And then curly brackets, if it's doing more than one thing, but if all it's doing is returning A plus B, what can we write here? Do we need curly brackets? We don't. Yeah, because the fat arrow has an implicit return. It will do this for us if all we have to do is simply return one line. One more, a little harder. I would like to filter out and receive only the even numbers back. So with pre-ES6, we would say new array equals array.filter, which receives a function and gives us access to each number in the array. And we can return the number if it's divisible by 2. And I would like to write this in ES6. So Aaron, if you'd help me, please. I'll do the declaration here since it's not a function. New array ES6 equals filter.
It's going to be number. that arrow.
That
It's
arrow.
gonna be number modulo 2, which will be 0.
Cool. Any questions on how that's spelled? That's right. That's how you would write it. Two functions do the same thing, right? The only difference is we're not saying the word function. We're not using curly brackets with our return. We're just saying number, because this is a function. We don't need parentheses since it's a single argument. So we can say with each number, only return the number if the number divided by 2 equals 0. Or has a remainder of 0. So, I mean, this takes practice, obviously, but hopefully you're starting to see the change a little bit, where we're going to be writing this way for as much as we can going forward. Is there any specific questions that those ES6 exercises we're giving you that you'd like to go over? I don't know if there's anything that we're getting stuck on. If not, we'll move on to rest and spread. Yeah.
More than one statement, so you put in brackets, you still have to put return.
You have to say return if you don't use the arrow. Yeah. Oops. Yeah, which one? Is it the reduce? Yeah, let's do the reduce. Which exercise are you looking at? What's the label of it? Is it this one? Let's see. No, it's not this one. It's the array reduce exercise. And is it, are we on this last one? Or which one? So the hardest one is this one. Yeah, I think this is worth spending a minute on. So we're going to pull all of this in so we have our question. And our data. All right, so this is a pretty standard of a question, but it's kind of a full question. So let's break it into parts. Given an array of potential voters, which we have here, it's an array of objects. Return an object. Okay, so return an object representing the results of the vote. Include how many of the potential voters were in the ages 18 to 25, 26 to 35, 36 to 55, and how many of each of these those age ranges actually voted. The resulting object containing this data should have 6 properties. So it says see it below. This is really common. You'll be given data, you'll be given the function to build, writing all your code in here. And then it's giving you one test case. It says, hey, if you call the function with this array of voters, this is the object we want back. Saying, this is how many youth were involved, this is how many of them actually voted of our 3 ranges. And we're asked to do this using reduce. Now, what kind of data type does reduce return? Whatever you tell it to. So if we need it to return an array, a string, a number, an object, we have the option to tell it what data type we're building. So we need to reduce, we need to crunch this array down to this object. And reduce is perfect for that. So let's do it. Let's say const result object, the thing that we want to return, is our voters reduced into some set. Let's do ES6. So what is the parameter or parameters that reduce requires? What does a higher order of method usually give you right here in the function? So here's the function. We usually get access to something like number, right? Each item in the array. So that would be like voter for each voter. But that's not how reduce works. Reduce's first argument is actually what we're building. And I'm going to call it final. But this represents each individual voter as reduce loops over the array, and final is the piece of data that I'm building that will eventually be returned when reduce is done looping and will be saved into result object. Now I need to tell reduce what data type this is, because by default it will just look at the first item and say, you plan on returning an object that looks like this, so I'm going to build on it. And we don't want it to do that. We want to start fresh. So how do I tell reduce what to start at? What is your starting point? Because here's our first argument. Yeah, we have to define final. So the first argument is the callback function. The second argument is what is final? What should final start off as? What are we building? We want to build an object. So it end up looking like this with this random set of curly brackets at the bottom. But that's just the reduce syntax. We say, hey, give me access to each voter. We're going to be building this object from the data that each voter has, and this is what you want. This is what final starts as. So if I were to console log final inside of this function, we'd see an empty object. So now while I'm looping through this, I need to build this object. But how do you build an object, key and value at a time? So if you need to output an object, like create objects, a constructor function would be good, but we're just creating a singular object through this. Yeah, so I could, in this object, I could give it all the keys it needs. So I could say start off with I'll break this apart, young votes, 0, youth, 0, mid votes, 0. And I can tell it really what to start the object as, so I don't have to create the keys dynamically. This can make it a little easier. Right, so now I'm saying final start off as this object, and then I'll add to this object or increment these values as appropriate, so I can get this output object at the end. And now we just have brackets everywhere, and it looks great. So the real question is asking this range, 18 to 25. Let me grab these 3 ranges so we know what our ranges are right next to this. So 18 through 25 is youth, 26 through 35 is mids, 36 through 55 is olds. So how would I see if the voter's age lands in this range? For example, how would we check if it is in the 18 through 25 range? Yeah, so this voter item right here represents each object. So each voter has a voter.name, a voter.age, and a voter.voted. And I want to see if their age lands in this range. Voter.age is, we're going to have to ask 2 questions here, right? We're asking if it's in a range. So if it's greater than or equal to 18, but then how can I say also make sure it's less than or equal to 25? And voter.age is less than or equal to 25. So if that's the case, we need to add 1 to this property, youth votes. So can I just say that, youth plus plus? What is youth a property of? This is of final. Final is this object. So we have to say if the voter.age lands in this range, then the final.youth property, increment it by 1. And that will change this property to have a 1 in it. Now we can't increment, this may not work. Let's test it out right now. So what is one word you have to include with every higher order function except for each? Return. And what do you have to return on each iteration? Yeah, you want to return this so it knows what it ended at last. so that the next time reduce iterates, it can keep adding to this. If we don't return final, we lose it as reduce is looping through the array. So regardless of what we do to final, how we change it, we want to return it every time too, so eventually it can give us the final result here. So if this works, we should see youth has a 4 in the output object. And we get this big error. Sum has already been declared. It's not even what we're working on, it's something we did earlier. That's better. Undefined. Oh, well, here's my ending of my reduce. Why am I getting undefined when I call this function? Yeah, notice that VS Code is saying this isn't highlighted. It means we're not using it. And this is what we actually want out of the function when it's done. So how do I get this out of the function? Cool, what line number will I return this on? Here? Here? Here, okay, yeah, after the reduce is over, cool. Result object. So all of this is just the reduce. Now we can test it and see what our object looks like. Scroll up, and sure enough, we've got 4 youth voters by asking if they fall in this range and incrementing that property of the object. Well, it asks us to go a step further. We also need a young votes that is equal to 1, because out of the 4 people in this age range, only one of them has a voted status of true. So if they land in this age range, great, let's add them to the age range. But then how do we check if they also voted? If voter.voted. Why can I ask just if voter.voted? Why don't I mean, I could say this. Yeah, voter.voted is already a Boolean. It's already true or false. So asking if true equals true is redundant. All we have to say is if this is a true value, then that means they also voted. So how would I then increment the young votes? Young votes increment. All right, so here's the object we got the first time with 4 youth voters. Now we should have 1 here. Let's see if this works. And sure enough. So how would we then account for mids and olds? This same statement 2 more times. Yeah, so just this. I can copy it twice and then change the ranging. So 26 through 35, great. This one is going to be 26 through 35. And that means it is a mids. And if they voted, it's a mid votes. So instead of final.youth, final.mids. And if they voted, final.midvotes plus plus. And the last for here, which is the range 36 through 55. And this is old and old votes. Is 36 really old? Is 55 really old? I don't think so. Who wrote this? Some young, wide, bright. What's that? Oops, you're right. I was changing the wrong thing. Good eye. Old and old votes. Okay, so once I worked out the logic once.
54 is olds.
Olds. That makes sense. Olds is a word. Olds and old votes. Okay. So let's see if when we repeat this process like we did with the first one, if we get the final object that looks like we hope it does. Spelled mid wrong? Mids and then mid votes. Yeah. Yeah, we got that one. Just the old. So 1 4 3 4 3 4. 1 4 3 4 3 4. So that is taking an array of objects and reducing it down to an object of the count that we want. So, I mean, this may not make perfect sense just yet, but if anything, grasp from this the power of reduce. I give you data, maybe statistical data, and you reduce them into powerful statistics because you're given access to each item at a time and can crunch the numbers to give some sort of output effect on our data. So I'll put this in Slack because it is a tough one. We can look at another way to do it at some time where we don't have to build the whole object first like this, but any questions on how we did that? Looks like a lot of code. I'm gonna change that to array. Okay. I'll just put this in Slack. Okay. So just to keep working along the lines here, where do you see the rest operator when you're using an ES6? There's only one place you can use the rest operator. As a parameter of a function, yeah. So let's say we had a function that needs, the user can give them as many numbers as you want, and you want to return the largest. Well, how many numbers are they going to give you? 2, 5, 10? It will vary. So to make that work, we can say ... nums or ... numbers, whatever we want to call the parameter. And then let's console.log numbers. So we'll find our largest number out of the set of these numbers. When I run this function, what did rest do to all the numbers? Yeah, put them all in an array. So it doesn't matter how many numbers I pass in, this operator will gather them together and put them in their own little box so that I could then loop through this array and work out the logic. But simply put, the rest allows you to gather an innumerable amount of arguments into a singular array called by whatever you name the parameter. So what symbol specifies the spread operator? Yeah, it's the same syntax. So let's say I had array 1 and array 2. And I want them to be one array that has the numbers 1 through 8. So I declare a new array. And then how do I move the contents of both of these into this new box? ... array 1. So spread all those, just literally dump all the contents of array 1 into this final array. Then also dump all the contents of this other array into this new array. Yep, you can do as many as needed. Fortunately, we'll console log final array, and we get our full deal. So spread works on arrays. What about objects? I have one object. I have 2 objects. But we really need this to be one object called person. So how do I spread the contents of object 1 and object 2 into person? ... object 1, ... object 2. Now I'll console.log person, and we get the spread contents into 1. So you can't spread the contents of an object into an array or an array into an object, but if they have the same box shape, meaning if it's an array, I can dump them into a new array. If I have objects, I can dump them into a new object. It does not change the original object. It's making a copy of the values inside and moving them over. So person is both of these combined, but these still exist on their own. And that's it for spread. Any questions on dumping box contents?
Wasn't there only one higher method, array method, that changes the original?
Sort. Sort will change the one you give it to. You give it an array of unsorted numbers and sort it. That array is now permanently sorted unless you made a copy of it first on your own. But yeah, all the rest will return a new array except, or a new piece of data except for each. Okay, so that's rest and spread. Object and array destructuring. Run through these, one more here. So player equals Excalibur, weapon, a fish, and catchphrase. Oh no. Okay. And I would like to console log this sentence. Console.log player.name hits the enemy with his player.weapon and shouts player.catchphrase. What is not dry about this statement? And if we need to reiterate what dry stands for, do not repeat yourself. Where are we repeating ourselves in this line? Player, player dot, player dot, player dot. It's not a whole lot of code, but wouldn't it be nice to just say name hits with weapon and shouts catchphrase? So object destructuring was given for this. Now let's run it once just so we can see the output sentence. Excalibur hits the enemy with his fish and shouts, oh no. Well, I'm going to destructure this. And what that means is says, pull each of these properties out and give them their own variable name. It doesn't change the object, but allows us to say all of these words without first having to say player. The way you do that is you actually declare a new variable, but this is a multiple type of variable, so we have to open up object brackets and say we're going to pull stuff out of the player object. Well, what do we want to pull out? We want to pull out name, weapon, and catchphrase. Catch parse. Now I can get rid of every instance of the word player and just use the words. So this is kind of like I don't have to pull every property out. So in this case, I would still have to say player.catchphrase. But if I run this now, it runs the same way. It just named these variables for me. It's like a shorthand syntax. Nothing magic going on. In the background, what it's doing is it's saying, great, create a variable called name and set it equal to player.name. That's what this is doing. And then it does the same thing for weapon, same thing for catchphrase. Saving us the time of having to do that ourselves, we can just say pull it out. So arrays have the same ability. You can destructure items out of an array, but since arrays are sorted by index numbers, the order in which you pull them out will match the index number perfectly. But it works the same way. Any questions on destructuring? I'll be using this all the time, so especially once we'll start React next week. We get into this syntax quite a bit. Moving right along then, a quick stop at string literals. What was a string literal an improvement on top of? What did we used to have to do to put strings together? Yeah, we used to have to concatenate. But wouldn't it be great if we had some sort of operator that concatenated for us? We do. So before I would say Steve plus, not Steve, name plus says hi. We'd say Steve says hi, but now we can say console log backtick, $, curly brackets, Steve says hi. So just introduce the backtick syntax, and that's what string literals are. They're also referred to as template literals. This is much more of a template look rather than concatenate. Stop me if you have questions. We'll keep moving along though. Constant let. What are the differences between constant let? Yep, let can change, const cannot change. And then what is the big difference between constant let versus bar? Scoping. They are something scoped when bar is local scoped. So what is the new scoping that these have? Only if we declare them global. But what if we declare them inside of a function or in an if statement? They're scoped to the nearest set of what? Yeah, they are bracket scoped. So where if I had something like this, I can still console.log a because bar, wait, what did I do? Oh, okay. Where's name? It's my bad. Because var is not bracket scoped. If this was wrapped in a function, it would be local to the function, but this is actually a global variable because of how var works. But if I change this to, so let's say let, what will happen when I console log a now? Undefined, because it only lives on line 140. It disappears after that point. It's scoped to the nearest set of brackets. And those are the three differences, the three main points of this. Okay, object literals. I'm not sure if we covered this, so let's cover it now. Object literals. Well, destructuring is nice because it saves us from declaring new variables the manual way. We can just say it all in one line. But what if I wanted to create an object from a bunch of variables without having to manually do it? So let's see what that means. We're going to make a const enemy name equals, it's a good enemy name, Dr. Evil, yeah. Const enemy weapon equals death laser, and enemy age equals 20, 30. I would like to make an object that looks like this. Const evil guy equals, and has a dot enemy name equal to Dr. Evil, and has all the properties, but right now all I have is separate variables, and I want to make an object from this. Object literals, I don't have to do this, where I say make an enemy weapon property of the object and set it equal to this variable. What's bad about this syntax? What rule is this breaking program-wise? I am repeating myself. I should not have to repeat myself. So object literal says, if you have a variable by the name of enemy name, you don't have to tell me to make the key and the value. Just give me the variable. I will make the key and the value for you. So it's a shorthand syntax for creating objects off of already existing data. So all I have to say is this object should have these keys. It'll look here and find these values. And so if I console log evil guy, getting creative with my variables so we don't hit errors. This. it created the object for me. So this is object literals. I can just literally put the name of the variable inside the object. It will create the object, key value pair for it.
That's a function.
That's a constructor function that outputs objects. This is saying I just need to make one new object off of some variables that already exist. This syntax is mostly used for exporting from a file, right? Because if I'm exporting a function called sum, I don't want to have to say this and then subtract, and keep doing that. I could just say sum, subtract, and export multiple functions without having to repeat myself. That's object literals. We'll see more. And default parameters. What are they for? Let's use our favorite simple function. Sum takes two numbers and returns their sum. But what if I call the function like this? Oh, not like that, sorry. Like this. What's gonna actually output here? Why is it not a number? B is not a number. So how could I say, if they don't give you the B, I will give you a default number to use? What's the syntax? You say B should be equal to 20 or 10 or any number if they don't give you one. Yeah. You can say if they don't give you a number, that's the number. If they do give you a number, forget about 15, use the one they gave you. So if I run this right now, what should I get? 35, 35. But if I pass in the number, now I should get 25. And that's all the ES6 features as fast, well, not as fast, but as concisely and clearly as we can put them. Ones that you'll be using a lot. You won't be using default parameters a lot. Very special situation. Object literals, we'll be using that more and more. Constant let every day. String literals, really whenever you want to concatenate strings and variables, you should be using this instead. Object and array destructuring, we'll be using that in a React a lot. Same with spread and rest. You won't use rest a whole lot, you'll use spread a lot. Array destructuring? Yeah. Yeah, so here's how we did it with the object. We said pull these properties out. Let's do it with an array just so we can see it. And I would like to deconstruct those three items out. So I don't have to say const Rick equals names bracket 0, const Morty equals names bracket 1. I don't want to have to say this. So instead I can deconstruct these three out and give them names. Destructure and deconstruct. Yeah. Yeah. So instead of just being able to give it the name like we did with objects, we have to pay attention to the order they're in, because that's the order they're destructured in. So instead I can say const destructure the following box, which is names. The first item that's in there, call it Rick. The second item that's in there, call it Morty. The third item that's in there, call it bird person. And that's doing this for us. Well, if I wanted these three as variables, I have two options. I have to write it one by one or all at once. Yeah. So when I console log Rick, what should I see? I'm going to console log Rick here. Which one of these three names will I see? The first one, because when I destructured the array, whatever I called this here, I could call it literally, I can call it literally anything. And now when I console log literally anything, prove it. What What will this string be now? It's still rig, yeah. Represents the first item of the array. This represents Morty, bird person represents bird person. Yep. So same as object destructuring, except order matters. Where object destructuring, I could say this in any order, it will still do exactly what I asked, because there is no order in an object. Doesn't matter what order these are in.
Let's just say you needed to create multiple variables, you have to save them.
Yeah, destructuring is just to save you declaration lines. Like this right here. This here. Oh, because object doesn't matter on the order. So this is creating a variable called name equal to Excalibur, a variable called weapon equal to fish, so that on the next line, I didn't have to say player.name, player.weapon. Yeah, because objects aren't ordered. They don't have index numbers like arrays do, but arrays are strictly ordered. This is 0, this is 1, this is 2. So I have to destructure in that order, because even if I call this first one Morty, still stands for Rick. If I call this one Rick, it stands for Morty. Order matters.
But also in an object, you're looking for, like, what he's putting in there, weapon, name, and catchphrase, those are all keys inside of that object. So it's saying, look for a key called this inside of that object, and that's why the order doesn't matter. It's looking for that key.
Yeah, it'll look through the whole thing until it finds weapon and then create the variable, where this one won't look for Rick, Morty, and bird person, because I could call this item 1, item 2, item 3. And if I console log item 3, what would it be? Bird person, yeah. Yeah, everything right now is conceptual. Like, you'll see it in action eventually. Knowing, a big thing of programming is knowing your toolbox before you necessarily have to use your tools. So knowing what exists, so when you hit a problem, your mind can open up to possibilities. And then that's when you start getting practice using it, but conceptual. That was the ES6 review. Took a little time, but that's all right. But now onto the main stuff for the day, Ajax, Postman, and HTTP. And I put these here because this is actually going to start a lesson and exercises for this morning. Yeah. So I'm going to make a new file here. I'll call this one ES6 review. And let's talk briefly about HTTP. What does it stand for? Oh, I forget I have my name generator. One sec. Somebody lucky is going to get called on. Mirette, what does HTTP stand for? Oh, okay. Oh my. Phone a friend. You can ask the audience too. You only get one of those. Hypertext. What is hypertext? Okay, so hypertext transfer protocol. So breaking down the acronym, what is hypertext? Where else have we seen that word? HTML is a hypertext markup language. So this is the transfer protocols for transferring hypertext across the web. How do I get my web page from my server in India to your computer in California? HTTP, the transfer protocol. That's how I get it to you, and you can get me stuff back. Well, how do they know who asked for the data? There's a trillion computers out there. Yes, so you are identified by your IP address, your internet protocol address. What is the protocol that runs the internet? HTTP. So your internet protocol address is your address for HTTP. People know who's requesting it, can send you back to web page when you hit their website. Well, I'm making requests to a server, they're sending me responses back. What is that cycle called? Kind of like a circle. I send a request, they send a response. If you had to put that in the form of a cycle, I send a request, they send a response. What is that cycle called? It's called the request response cycle. Yes. Okay. When I make a request, like go to google.com, I'm sending my request to the back end. What is the first thing that gets my request on the back end? The server. So the request response cycle is how web servers and web browsers communicate. I send a request, the server receives it, goes and handles it with other code, eventually has the response and sends it back. If we can refer back to this image from last week, here's us, we send a request, the server receives it, sends back a response. And we're just going to be studying this loop for the next little bit. Then we'll jump into React to learn client again, and then we'll jump into this again. Once we know React, then we'll jump into providing our own data for it. Any questions on the process at a high level again? Okay, neat. If we had to specify quick A word, I don't know. Representation for how to think of the whole full stack process, front end to back end. Think restaurant. Who takes your order? Which we could also call a server. Server takes your order. Does the server cook your food? No. Does your server go buy the food? What does the server do? It takes your order and then eventually does what? Takes your order and eventually brings you your food. The server has no process, no involvement with the preparation. They're not licensed. Who is licensed? The API. Yeah, okay, so this is in the, we're thinking restaurant that can handle this large of a staff. But so the server takes the order and eventually brings back the food. But when they take the order, it hands it off to the API. API actually prepares food, buys food if needed, adds food to freezer. The API is all the interaction with the database. Get me this, take this. Once the API has the stuff from the database, API gathers this from the database. API is the kitchen. Well, once the API has everything prepared and ready to go, who does the API send it back to? Yep, server receives prepared meal and responds to customer, which is the client or the computer. It sends it back. And this is the back-end process. Always think restaurant, because the server doesn't know what we're actually needing to have done. It just knows what the request is and passes it off to the kitchen that knows how to handle it. That's the API database. Then the server gets it back once the API is done and sends it back to the client. Cool? Getting it a little bit conceptually? Okay. Well, when I request data from a server, what format does that data come back in? In the form of what? What language does this data get transferred as? JSON. Why JSON? Well, JSON's super light. It's just text. Everything is converted into a big giant string. That's what JSON is. So it's a split second to get you your 10,000 items to your front end so you can make them show up to the user. It's a lot faster just to transfer a little bit of string, where in the past, instead of just transferring JSON, they would transfer the entire web page, which includes HTML, CSS, and JavaScript. This is referred to transferring as XML. You'll still see it, and some APIs still only transfer as XML, and unfortunately, if you encounter that, it's kind of a no-go. Unless you really want to go in that rabbit hole, we're looking for JSON. In the past, transferred the entire web page as XML. Great.
What about for people that are programming in other languages?
It would. Yeah. And there's other forms of JSON. There's JSON-P that like Python and such can work with better. But regardless of the backend you're using, whether it's Ruby on Rails or Node with Express like we do, JSON is still the transfer method. If you have a server-side rendered app, which we'll talk about later, XML is still common. You can write server-side rendered applications in Node, but we won't be writing those here. We're going to be writing front-end React applications. Okay, so that's HTTP. But then we get these two tools, Ajax and Postman. What is Postman used for? I'll give this to Nathan, not myself, other Nathan. Why do we have Postman? There's multiple correct answers. So even if you think it's maybe not right, it could still be partially right. Cool. It allows us to do what kind of request saves in the database? Post requests through Postman to save things in a database. Okay, that's one thing it does. What else does it allow us to do? Allows us to do GET requests to see what the JSON looks like. We really want to know what our data looks like before we try to program with it, because if we don't, we could get lost pretty easily. We ought to see what this response object looks like. Eventually, we'll be using Postman to test our own server API database. So in the latter half of the course, we'll be using Postman to test our own code. Right now, we're just going to use it to check other people's APIs, see what it looks like, test it, and then make an application around it. All right, so we've covered get and post lightly here. But what is the acronym used to describe the 4 common request types? CRUD. C-R-U-D. So randomly here, Ryan, give me one of the words that this acronym stands for. It can be C, R, U, or D. And then the request type it matches up to. Create, or U is create, no, C is create. And what request is that? Post, great. Chris, it's another one. Update, D for update. What does update, what request is that? Put, yes. Hannah, R or D? Destroy. And which request is that? Delete. I'm hearing the words. Didn't sound like Hannah, but. And then lastly, Aaron, what is R? Close. Retrieve would make way more sense, but they didn't choose that word. Nope, that would make even more sense, but no. No. What do you do with a book? You read it. But what request is that? Get. All the words you chose were arguably way better than the word they chose, but you're wrong, they're right. This is the acronym. We get to work with it. Okay, and so today, this morning is going to be focused on these four. We're going to have you do all four of these in Postman because the next project is to make an application that does all four of these requests using the To-Do API. So you're going to make a live to-do application that you can visit tomorrow and you'll still have all your to-dos. You'll be able to update them, delete them, get them, and add to them, all using the website you create. So this is going to be a website that includes forms and JavaScript, and XHR objects, and all that fun stuff. But we will get into Axios today after reviewing XHR, which will make this a little bit easier to manage. So now we're to actually using it. What JavaScript constructor function allows me to do an asynchronous request to a server? XML HTTP request. If you're forgetting the word, think XHR. It's the acronym for this, XML HTTP request. And that creates an object we can use to interact with the server and let our program keep running while that's happening. Ajax. Well, I would like to make a GET request to the vSchool to-do API. So I'm going to go to coursework, vschool.io, and I'm going to look up vSchool API documentation. And it says, for a GET request for all to-dos, here is your endpoint. Now, before I throw this in my application, where should I throw this? Postman. Let's go to Postman. And I'll just put in the URL here. Oop, and I'll change this to a GET request. But I need to put my name in this place. So I'll use the one I was using last week, Nate JE. I'll hit send. And down here in the response window, I get my response. Can you type in the response window? No. You can only type in the request window. You are the requester, not the responder. So this is simulating front end. This is simulating what's coming back from the back end. So I just did a GET request to this URL, and this is what I got. So now I'm ready to go implement it in my code so I can see what my data looks like. So I'll grab that URL, and I'll pull it into here just so I have it. And now how do I open an XHR request? XHR.open. It needs two arguments. Does anyone recall what they are? Yeah, the request type, so GET is the one that we're going to do, and it has to be in all caps. And the second one is the URL. So make a GET request to this URL, and then how do I send it? XHR.send. Right, so this is going to go out, but XHR has a specific function that will fire every time it makes progress. What is that function called? It's not a... On ready state change. What does that mean? What is ready state? Yeah, what are the levels? How many levels are there of the ready state? 4. And which one means it's done? 4. So when the ready state hits 4, when this function is going to get fired 4 times, but on the 4th time, we're going to check, is it done? If so, we're ready to work with it. So we're going to ask if the XHR's ready state equals 4, our response is back. But what is the possible result of our response? Yeah, we could have an error, or we could get the stuff we asked for. So what? How do we tell this to also make sure if it's came back in good order? Yeah, their status. So I'm going to ask, is it done? And was the status good? And what's a good status code? 200. Everything's A-okay. At this point, whatever code I write on line 41 will only happen if it's back and in good order. So what part of the XHR object will have my response at this point? Let's look at it. And I agree with you, but let's look at it. Let's see if we have an HTML page hooked up to this. We do. Wonderful. Let's go live. And here is our XHR object. Great. So we see in here it has a response text. What data type is the response text? No. No. It's a string. JSON is a string. It's like, wait, isn't this an array of objects? Yes, once we turn it into JavaScript. But when it's JSON, it's always just a string. So how do I turn my JSON response into JavaScript I can now work with? JSON.parse. They all shout together. Yeah, so I will tell it to JSON.parse my XHR.response text. And this will return my JavaScript data, this same data in the form of JavaScript. So now I will console.log data. And that looks more friendly. There's JavaScript.
Pretty much we'll use that exact function every time.
After today, you probably won't have to write it again because we're going to introduce Axios, which does all this for you. But if Axios, every single time, yep. You may add this function may be huge because you want to handle 200 requests, 404, 500, all the different types of errors that could happen. But base form here, this is exactly how it will look. What's that? Yep, any API. As long as the URL is an API endpoint, this will be the data from that API. Well, what would happen if I console.log data out here? Yeah, data is not defined. Why? Well, not only is const function scope, it's block scope. So it doesn't even live in here, it lives in here. But I need to use this data later in my program. So what is the easiest way to get data from one function scope to another? Yeah, I can create a function and then call it right here and pass my data to it. So down here, I'll make a function that says accept data, just to be straightforward. And it's going to receive data as a parameter, this is a placeholder, right? It stands for anything. Well, up here, I'm going to say, call my function accept data and pass the argument data into it. So this receives it, and now I can keep using it. If I console log data now, we're back to seeing my array. But this is on app.js line 47, showing us it is, in fact, still alive and well right here. So questions on this setup? I know this is a hard thing at first to see.
So this data is already built in.
I made this function up. Okay. No, that my answer is no. I made this function because I need to use this data after it's come back. So I write the function so that I can call it at the appropriate time, right? This will only happen once it's back. So I can call my function and pass it the response so it can receive it and then just keep using it. But
How is it working when the previous function is before it?
this is hoisted because it's a function declaration, so really it's declared right here. Right, but if I said this would not work. So this function expression would have to be up here.
Function is global, but now you're saying that it doesn't matter where a function declaration is declared, global throughout the entire JavaScript.
Exactly. So that's why I'm just using declarations here, so it's a little bit. Okay, come back down. There we go. One step further, I would like all of my to-do titles to show up on the DOM. So we should see my very first to-do. This is my second. And this is my third. Well, let's get the first one to show up and then tell our computer to repeat it. So I'm going to grab the first object out of the array. Data bracket 0. Right, we have an array. This is grabbing the first object. So this has a dot title, a dot description, a dot completed. What is my process to get this object's title to the DOM? 1, create element. Great. Const p equals document.create element p. Cool. Step number 2. Edit element. Let's add some text to it. So the p's text content should be what? How do I get the title out of this object and tell it to be the text content? I would have to say 0 if I didn't do it here. Yeah. Okay, step 3. Append. Put on DOM. Well, I don't have any elements really on the DOM right now to put it in, so I'm just going to put it in the body to be straightforward here. So I'll say document.body .append a child, the p tag. And instantly we'll see my very first to-do pop up. Which is cool because this came from the server and now it's on the web page. But there's 3 items in this array. There's not just one, so how do I repeat this process for as many items as there are in this array? A for loop or a for each, however you'd like to do it. But let's do a for loop. What is the stopping point for this for loop? The array, length of the array that we're passing in, which right now is 3, I++, and we'll put the closing bracket after everything we want repeated. All I had to do was that, and magically, voila. Nope, not voila. What's wrong? I did it 3 times. Yeah, so what do I need to change about this? I'm going to get rid of this first line completely. So how do I now have it not break and actually print out all 3 items? Yeah, we no longer have to do, we have our data array. So how do I say grab the current item out of the data array? Data bracket I. And now we get our 3 individual. What's cool about this is once you get this pattern down once, why don't we repeat it and get a another p tag, which we'll call p tag. And we want to put the description in this one. Same thing, but we just access the different item of the object. And then append it to the DOM. Aha. Content. Now we're getting the title and the description to show up for each object. Now it's getting a little hard to see how many to-do items do we actually have on the view right now? 3. Here's 1, here's 2, here's 3. So I'd like to put a border around each one. But how do I do that? They don't exist on the DOM until we make our server request, the data comes back in this function fire. So how do I put a border around each of these? Okay, so I could, well, right now they're just kind of floating tags, right? If we went and looked at the DOM, we're just going to see a body tag with 6 p tags in here. So how could I group these? These 2 into 1, these 2 into 1, these 2 into 1. A div. Where would I create that div? Would I hard code it on my HTML page? Do I know how many divs I need when the page loads? No, my server could send me 5 items. This could send me 10 items. So that means I need to create that dynamically, just like I'm making the p tags. So I'll make a div. And then instead of appending the p tags into the body, I'm going to say append them into the div. And then I will append the div to the body. Now visually, nothing has changed for us yet, but if we look at the actual HTML markup, we now have 3 groupings that have 2 p tags each. And this is much easier to style. We can give the divs a border, and each one will have its own little grouping. And the nice thing is, since this is a repeated process, just like creating the tags once, I only have to declare the style once, and even if there's 100 items, they'll all have the same look. Because this happens 3 times, so we're making 3 divs. Yep. And const is just fine here because once this iteration ends, it's trashed and it starts again. Bracket scoped. All right, so now let's add, what would I add the border to? Yeah, so I could do this one of 2 ways. I could say div.style.border equals a 1 pixel solid, black border. And now they're nice and separated for me to see. But if I want to style them intensely, maybe there's 15 properties I want to give it. This is going to be not dry, if I can say it that way. So instead, how could I add a class to each div and then go do my styling in CSS? I wouldn't say this. How do I add a class to the div? Div.classList, which has 3 methods, add, remove, and toggle. Well, I would just like to add a class. I'm going to add a class called to-do container. Nothing changed because I don't have a style sheet or any CSS written. We'll go into here, go to style CSS, and now the name of our class is to-do container. So I'll go in my CSS, make it to-do container, and say your border should be a 1 pixel solid black border. And they all get it. And this is nice because now I can say, inside of that to-do container, there's 2 p tags. I want the first one to be red and the second one to be blue. The to-do container, I can say the p tag that is the first item, the nth child of 1, your color is blue. And then in the to-do container, the p tag that is the second item, make it red. And I can do all my styling in here, and this is going to repeat it out and do it for all items. Now, you probably haven't seen the nth child before. That's fine. You don't have to do it this way. Just know it's a way to grab specific numbered items inside of a div. Here's the first nth child of the p tag, second of the box. But you quickly get yourself into a list. It starts looking nice. So now we can space them out a bit. Okay, that's looking more tweet-like. Be a border radius on them all. I give them some padding so they're not touching the borders. Okay, I mean, these aren't obviously well styled, but to show you, I only have to write the CSS once. My for loop's generating the items that all have the same class, so they're all getting the style. Minimal code for maximum output. So one more thing and we'll take a break. Let's clarify what type of programming this is. If you had to sum up what it feels like to tell a program to list this out, what words would you use? Functional, that's fair. So it's a functional. Maybe if I can better phrase the question. What's that? manipulation. These are kind of high level terms, more of you as a person. How does it feel to write each line? Like create the item, put the text in the item, then put the item on the DOM. Yeah, it's what if you had to make a sandwich that way? You know, grab bag of bread, open bag of bread, put hand in bag of bread, pull out piece of bread. It's very, very step by step. And the word for this in JavaScript is imperative. This is imperative programming. It's very step by step. You have to tell it every single instruction. Well, imperative, while you can do everything with it, it's extremely long-winded. So another type of programming is declarative. And this is like our filter. We say array.filter, give us the number 5. We can declare what to do, and then it goes and does it, rather than saying, when you go to a restaurant, where would you like to sit? There's 2 of us. We would like to use our feet to walk over to that table that has 2 chairs by the window, versus there's 2 of us, and the waiter knows where to take you. So we've been writing imperative. We're going to keep writing imperative for a few more days, but then we get to React, where it's all declarative. I say one thing, it does 100 things for me. Step by step. Hey, you do this. And then whatever is responding says okay. All right, that's it.
Taking permission from the API, already know how to display it.
Yeah, we'll still have to tell it how to display it, but we don't have to do it like this. We don't have to say create an element, put the text into it, then put it on the DOM. In React, all we have to say is create a div and put the name in it, and that's enough. It does this whole process for us. So this right here is mixing these 3 steps together. This is React syntax. This is vanilla JavaScript syntax. Now we can see why there's frameworks, or we're beginning to see. And there's a common phrase, if you don't use a framework, you'll end up writing one. All right, I'm going to stop the video so we can